Hello everyone. Today we will be discussing examples about the continuous random variable. So let's have this problem. Suppose that f of x is equal to 1.5x squared for negative 1 to 1. Determine the following. The probability that x is greater than 0, the probability that x is greater than 0.5, the probability that x takes values in between negative zero point 0.5 and positive zero point 0.5, the probability that x is less than negative 2, the probability that x is less than 0, or x is greater than negative zero point 0.5. Find x such that the probability of the random variable x taking values greater than x is 0.05. Also solve for the cumulative distribution function of x and the mean and variance for the random variable x. We have to take note that the density function given is a parabola. This is a parabola with vertex at the origin and it opens upward. So from negative 1 to positive 1, um, it is always positive. So it satisfies the condition for the probability distribution function. And also, we need to check whether the integral from negative 1 to positive 1 of 1.5 x squared dx would be equal to 1. So this would be 1.5 x cubed over 3 from negative 1 to positive 1. So this would be um, x cubed over 2 from negative 1 to 1, which is indeed equal to 1. Now, let us solve the given probabilities or the unknown probabilities. Letter A. The probability that the random variable x is greater than 0. So greater than 0 means it is from 0 to 1, which is the integral of 1.5 x squared dx from 0 to 1. You can use your calculator for this. However, I think it's quite obvious that since this is symmetrical and it is half, so this is 1 half. But we can verify that using your calculator for the integration. For the second one, so it's indeed 1 half. For letter B, the probability that the random variable x takes values greater than 0.5 would be equal to 0.5 up to the highest value of x would be 1. So that would be integral of 1.5 x squared dx. So that would be 7 over 16. For letter C, the probability that x is in between negative zero point 0.5 and positive zero point 0.5 is, so for the probability that x is in between negative 0.5 and positive zero point 0.5 inclusive is 1 over 8. So it's the integral from negative zero point 0.5 to positive zero point 0.5 of 1.5 x squared dx. So that is 1 over 8. for letter D, the probability that x is less than negative 2 is a probability of an empty space. So for that empty space, the probability is 0. For letter E, the probability that x is less than 0, or the probability that x is greater than negative 0.5 is the probability of a sample space which is equal to 1. And for letter F, the probability that um, x is greater than the probability that the random variable x is greater than x, so greater than x is 0.5, is the integral from from x to 1 of 1.5x squared dx is equal to 0.05. So this is equal to x cubed over 2 from x to 1 equal to 0.05. So that would be equal to 1 half minus x cubed over 2 equal to 0.05, and solving for x here, so we have 1 minus x cubed is equal to 0.1. So simply we have x is the cube root of 0.9. So x would be 0.9655. Number 2, solve for the cumulative distribution function of uh, f of x, or capital F of x. So if we are going to solve for capital F of x, it is equal to 0 for x is less than negative 1, and it is equal to 1 when x is greater than equal to positive 1. So in between negative 1 and positive 1, it is the integral of 1.5x squared. So it would be the integral is this one, x cubed over 2. So it would be x cubed over 2 from 1 to x. So the upper limit is x cubed over 2. The lower limit is negative 1. So it would be plus 1 over 2. So saan nanggaling yung positive 1 over 2? So that is, if we're going to substitute x cubed over 2 from x from negative 1 to x, so it would be x cubed over 2 minus negative 1 half, so plus 1 half. So that's why we have this one. For the mean, it is the integral of x times 1.5 x squared dx from negative 1 to 1. You can use your calculator for this integration, but by symmetry, I think it's quite obvious that the expected value is 0. And it is indeed 0. For the variance, it is equal to the integral of x squared, so x minus 0 squared times 1.5 x squared dx from negative 1 to positive 1. So, the variance here is 3 over 5. You can do your manual calculation for this one to verify results. We're going to solve this next problem, but this time using a software. Let us consider this problem. We are given with a probability density function given by f of x is equal to 3 times 8x minus x squared all over 256 for x is from 0 to 8. So first, we define the symbolic variable sims, the random variable x, and f of x. So for this one, we define f to be equal to 3 times 8 times the random variable x minus the random variable x squared over 256. We can simplify that. So this can be simplified as 3x over 32 minus 3x squared over 256. If we're going to plot this, easy plot of f, let's have it from 0 to 8. So we plot f along the interval from 0 to 8. The graph of the function is a parabola that opens downward. Let's have our grid on. And observe that from 0 to 8, you have this entire region located above the positive x-axis. So aside from that, we can have the area. So we want to check for the area of this. So that's the integral of f, where x is from 0 to 8. And observe that the total area is 1. So this is a valid probability density function. Now I want to take note that the function exists from 0 to 8. So we are going to take only limits from 0 to 8. So if for letter A, on letter A, we're looking for the probability that the random variable x is greater than 2. So when you say greater than 2, it is 2 and above. So that is the probability for A is equal to the integral of f. When you say greater than, it should be less than 2 rather. So it should be less than 2. So let's correct that. A is the probability that x is less than 2. So to get the probability of A, P of A is the integral of the function less than 2, so it would be from 0 to 2. When you say less than 2, So it would be from 0 to 2. So it would be the integral from 0 to 2 of f dx. So the answer is this one, 5 over 32. So this one is 5 over 32. For letter B, the probability of x less than 9 is the probability of the sample space. Less than 9, all the values from 0 to 8 is the sample space. So the probability for B is equal to the integral of f from 0 to 8. So that is 1. So this is equal to 1. Letter C is quite, I think, the easiest. So for the probability that x is in between 2 and 4, so it would be the probability that C is in between 2 and 4. So this is the integral of f dx from 2 to 4, and this is 11 over 32. For letter D, it's the probability that x is greater than 6. So P of D is equal to the integral of the function f greater than 6 would be from 6 to 8. So when you say it is greater than 6, so it would be from 6 to 8. So the integral from 6 to 8 of f dx. And to check that, it would be also 5 over 32. So letter A and letter D is quite the same because less than 2 is the lower portion, while 6 to 8 is the upper portion, which are quite symmetrical to one another. Now, for letter E, we're looking for x such that P of x greater than x, that the random variable x is less than x is equal to 0.95. So let us have first E to be equal to the integral of f. It would be less than x, so it would be from 0 to x. So we're going to integrate f from 0 to x. However, we haven't introduced a symbolic variable x. So we first define the symbolic variable x such that if we are going to integrate this from 0 to x, we have a cubic equation. We have this resulting equation. Now, what we want to do is to solve E equal to 0.95. There are three possible answers, so let's have it in terms of decimal. So we have 8.99, negative 3.91, and 6.9172. For this one, we are going to use a value that is between 0 and 8 because the function only exists from 0 to 8. So therefore, we use this one, 6.9172. So we use 0. 6.9172. And for the cumulative distribution of x, so we define capital F to be the integral of the function from the given lower limit 0 to an upper limit of variable x. So let's try to check whether we can simplify f. Let's expand it. And then so we have now our cumulative distribution capital F of x to be equal to 0 when x is less than 0, and it is equal to 3x squared over 64 minus x cubed over 256 when x is greater than 0 but less than 8, and it is equal to 1 when x is greater than or equal to 8. For mean is the integral of x f of x, while variance is the integral of x minus mu squared f of x dx. So for mean, it would be the integral of x times f of x from 0 to 8. So sorry, it should be capital X because the random variable is capital X. So the mean is 4. This is quite practical because it is symmetric. So the mean is at the center. So it is at 4. While for the variance is equal to the integral of x minus 4 squared times f from 0 to 8. So the variance is 16 over 5. For the next section, we're going to discuss this problem. So for this problem, we have the density function given by f of x is equal to x over 8. So again, we define the symbolic variable x with f of x such that f is equal to x over 8. If we're going to plot this, so we do easy plot of the function f for the interval from 3 to 5. So over the interval from 3 to 5, we can see we can see a line above the x-axis from 3 to 5. So this is 0.4.45, so definitely it's above the x-axis. So if we're going to have the area, it would be the integral of f from 3 to 5. So the area is 1. So it's a valid probability distribution. So this is okay to be our probability distribution function. It's okay. For the probability of x less than 4, it would be from 4 to 5 of x over 8 dx. Sorry, less than 4. Less than 4 should be from 3 to 4. So it would be from 3 to 4. While letter B is greater than 3.5. So it would be from 3.5 to 5 of x over 8 dx. While this one is the integral from 4 to 5 of x over 8 dx less than 4.5, so it would be from 3 to 4.5 of x over 8 dx. Less than 3.5, so less than 3.5, so that would be from 3 to 3.5, and then 4.5 to 5 of x over 8 dx. Let's do some integration. So for A, probability of x less than 4, so that would be P of A is equal to the integral of f from 3 to 4. So take note that this is not symmetrical. So we have 7 over 16. For P of B, that's the probability of x greater than 3.5. So P of B is equal to the integral of f from 3.5 to 5. So it's 51 over 64. For letter C, it is the probability that x is in between 4 and 5. So x is in between 4 and 5. So C is in between the integral of f from 4 to 5. So that is 9 over 16. For letter D, it is the probability that x is less than 4.5. X is less than 4.5. So P of D is the integral less than 4.5. So that's from 3 to 4.5. So that is 45 over 64. For letter E, it is the probability that x is less than 3.5 union with the probability that x is greater than 4.5. So P of E is the integral of f from 3 to 3.5 plus the integral of f from 4.5 to 5. So that's 1/2. For the second problem, we're now going to define the symbolic x and f of x again. This time, f is equal to e. We use exp for the exponentiation. So e raised to negative x plus 4. So we try to integrate the function from greater than 4. So from 4 to infinity. Doing that, the integral is 1. So this one, when you say greater than 1, so greater than 1, but it should belong to 4, greater than 4. So it is the probability of the sample space. So this is 1. For the second one, take note that it should be greater than 4. So this is the integral from 4 to 5 of e to the negative x minus 4 dx. And then greater than 5 would be from 5 to infinity of e to the negative x minus 4 dx. And finally, a to 12. So it would be from a to 12 of e to the negative x minus 4 dx. So letter B, it is P of B equals the integral of the function from 4 to 5. Let's convert that to decimal. So it's 0.6321. The second one, it would be from 5 to infinity. From 5 to infinity. So e to the negative 1. So it would be 0.3679. Actually, B and C are complements. While for D, is equal to the integral of f from 8 to 12. So let's have it in decimal. So it would be 0.0180. To study more about this topic, you may use the following references.